Hello everyone, and in this video we're going to be looking at a histogram question from an AS paper, but it is applicable entirely to both AS and A2. I picked this question out because it's got an unusual little kind of twist in it, which I know from experience caught a lot of people out. Okay, let's have a look at this question. It says the histogram summarizes the heights of 256 seedlings 2 weeks after they were planted. Use linear interpolation to estimate the median height of the seedlings. Now, the first thing I would say is that a histogram is used to represent continuous data. And when we have continuous data, in order to find the median, we can just divide the total number of data by 2. So in this case, we have got 256 seedlings, and we can say that the median, which is Q2, is equal to 256 divided by 2. So we get that Q2 is equal to 128. So we're looking for the 128th value. Now we need to determine which class interval that's going to fall in. So I think what I'm going to do is I'm going to represent this information in a table, I think. So I'm going to put CF for the cumulative frequency. I'm going to put the frequency there. I'm going to put the class here. Okay, so what have we got? Our classes are 0 to 1. Now let's have a look at that. So here we have got a width in this one of 1 and a height of 15. So we can see, remember that in a histogram, it's the area underneath the histogram that gives us the frequency. So we have a width of 1 and a height of 15. So we've got 1 times 15. So that is a frequency of 15, cumulative frequency 15. The next class is 1 to 2. Let's have a look. Again, we have a width of 1, but this time a height of 35. So we have a frequency of 1 times 35, which is 35, giving us a cumulative frequency of 50. Our next class is 2 to 3.5. 2 to 3.5. This one has an area of width of 1.5 and a height of 50. So that's going to give us 75 for our cumulative frequency. Our frequency rather, giving us a cumulative frequency of 125. The next class is 3.5 to 4.5 with an area. We've got a width again of 1 and a height of 55. So frequency 55. Add that on to our running total for our cumulative frequency gives us 180. The next class is 4.5 to 6.5. So here now we have a width of 2 and we have a height of 26. Okay, giving us 2 times 26, 52 for our frequency. Add that on to our running total, 232. And then finally we have 6.5 and goes up to 8. That's a width of here 1.5 and a height of, what's that height of? A height of 16. So that's going to give us a frequency of 24 when we do the width times the height. Add that to our running total, and that gives us our 256, which is good because we know that there were 256 seedlings. Okay, so now, and again, this is just rather like finding the median from a group frequency table in year 11. We've got to say to ourselves, right, which class is it that the median lies in? So we're looking for the class that contains 128th value. So here we've got up to 15, so it's not in there. We've got up to 50 here. At the end of this class, we've got to 125. And at the end of this class, we've gone up to 180. So the median is somewhere in this class. Okay, so it's somewhere in there. Now, there are different ways of using linear interpolation, but I personally do quite like the way that the Edexcel textbook has taught it, which I sort of refer to as the three-blob method. It's not very scientific, I know, but there you go. So what we do with this method for linear interpolation is we draw a line and we put 3 dots on the line, and then underneath we write down the value at the beginning of the class, which is 3.5. We write down the value at the end of the class, which is 4.5. So 3.5, 4.5 there and there. And we're trying to find the median, so we write down Q2 there underneath. Then above, we write down the frequencies. So the frequency at the start of the class was 125. The frequency at the end of the class was 180. And the value that we're after is the 128th value. So we write down 128, okay, like that. So now, in order to find our median, what we do is we say this number take away that number over that number take away that number is equal to that one take away that one over that one take away that one. So let's write that out. So 128 minus 125 over Q2 minus 3.5 is equal to, oh no, I'm so sorry. Getting myself a little bit mixed up there. So 128 take away 125 over 180 take away 125. So that one take away that one over that one take away that one is equal to that one take away that one. So in other words, Q2 minus 3.5 over that one take away that one. So 4.5 minus 3.5. Okay, that's perfect. So now all we need to do is just literally rearrange this now in order to work out what Q2 is. So let's just do that then. So, okay, so we're going to have 3 there, okay, and that's going to go over our denominator, which is going to be 3 over 55, and that is going to equal Q2 minus 3.5 over 1. We can now cross multiply. So I can say that Q2 minus 3.5 is equal to 3 over 55 times by 1. And then finally, my Q2 value comes from saying the 3 over 55 times 1, which is just 3 over 55, add 3.5. And let's work out, see what that is. So 3 divided by 55 is that, add the 3.5. Okay, that gives me a value of 3.55, we can see there from the calculator. Okay, so therefore Q2, the median, is equal to 3.55, and that is our answer. Okay, perfect. Right, that's part A done. That's quite a nice 4 marks, I think. But it's useful to look at that because I know that linear interpolation does cause confusion with some students, and yet it's very, very popular in exam questions of this type, especially with histograms. Now, this next bit is a little bit of a curveball here. So certainly, could be a little bit confusing if you were confronted with this first time in the exam. It says Chris decides to model the frequency density for those 256 seedlings by a curve with the equation y is equal to kx times by 8 minus x, where x is between 8 and 0, where k is a constant. Find the value of k. Now, unless you have an understanding of what's going on here with histograms, this could potentially completely flummox you, could very much confuse you. And what is actually going on is the thing you've got to remember is that a histogram, it's the area underneath the histogram that gives you the frequency. And the thing that we need to remember is that when we integrate, okay, so integration, if we have a function between here and here, when we integrate it, we're finding the area underneath the graph. So the common link between these two functions is that a histogram, its area gives us the frequency, and when you integrate underneath a graph, you get the area. So the inference is that what they're expecting us to do is we need to integrate the function between 0 and 8. And notice it's between 0 and 8, again, because that's the height of our seedlings. They go from 0 to 8. So if we integrate this function that Chris has come up with of kx times by 8 minus x dx, between 0 and 8, the answer is going to be 256. In other words, we've set it equal to the total number of seedlings, because remember, the seedlings is the area under the graph. So that's what we're expected to do here. So a little bit of an unusual twist especially, it requires you to have a certain level of understanding about how histograms work before you could realize what the right approach is. So let's take the k out. Let's do our integration. We're going to just expand the bracket, so I get 8x minus x squared dx is equal to 256. So that's going to go to 8x squared over 2 minus 1/3 x cubed, and that's going to all be between 8 and 0, with our constant k is equal to 256. So let's evaluate that now. So that's going to go 4 times by 8 squared minus 1/3 times by 8 cubed. Oh no, I'm so sorry. Oh yes, it is minus, yeah, like so. And then minus 8 times by 0 squared over 2 and minus 1/3 of 0 cubed. Okay, and there's a k outside the front of all of that, and it's equal to 256. Okay, so now we can just evaluate this and see what we get. This comes to 256k minus 512 over 3. Oops, our k's out there still. Let's pop the k outside. There we go. And then we're going to take away, that's 0 and that's 0. And that is equal to 256. Okay, perfect. So now we can just take these two brackets away from each other, make sure that k is not visible there. And that gives us 256k over 3 is equal to 256. So therefore that cancels, and we have that k is equal to 3. So we've evaluated what k is. So as I say, the link there was that we were expected to integrate. Now I have seen this kind of question come up a couple of times actually, this link with integration. So just one to look out for in histograms. Now, write down the median height of the seedlings. Again, what they're expecting us to do is just to recognize by symmetry that actually we can see that we've got a symmetrical distribution, okay, and we've got the highest bar here. So just using symmetry, we can basically see that the median height is going to be 4. Okay, so we can say that for the last part, for that 1 mark, we can say that the median height is equal to 4. And we're expected to deduce that just from the fact that the median means the middle, and we've got a symmetrical distribution like that. So our middle value is going to be there in the middle. And it does actually support that from the histogram, which has the highest bar there as well. So we're going to say the median height is 4. And that is the end of that AS/A2 histogram question. I hope that you found that useful, and I will see you in the next video.